So back to our quadratic equation. Now this one does factorise, but let's pretend that we can't do it. So the idea of completing the square. First thing we do is we move the constant number to the other side. So the 7 goes over. Then add half the coefficient of x squared. Now the pause is very important, of course, because you don't want to add half the coefficient of x squared. You want to add half the coefficient of x squared. So in this case, coefficient of x is 6, half of that is 3, so we add 3 squared. So we get x squared plus 6x plus 9. So what we have done is we've created a perfect square on the left-hand side. We have completed the square. So let's actually turn it into the perfect square. And there it is, x plus 3 all squared. So we're now saying something squared is 16. Well, if something squared is 16, it's either plus or minus 4. I can move the 3 to the other side and I have my answer. It's either negative 3 plus 4 or negative 3 minus 4. So minus 7 or 1. So that's the idea behind completing the square. Now that we know that, we can go and prove the quadratic formula. So let's make the quadratic ax squared plus bx plus c. Now when we complete the square, we prefer to have the coefficient of x squared to be 1. I've got a as the coefficient, so the first thing I'm going to do is divide everything by a. We'll move the constant to the other side, so there's minus c on a. Then we add half the coefficient of x squared. So the coefficient of x is b on a, half of that would be b on 2a. Square it, we'll get b squared on 4a squared. So b squared on 4a squared. The left-hand side then becomes x plus b on 2a all squared. Turn it into one fraction. Starting to look a little bit familiar there. You'll notice the numerator, b squared minus 4ac. Plus or minus the square root of b squared minus 4ac. And of course the square root of 4a squared, 2a. Now all I've got to do is move the b on 2a over. And there's our formula. So that's where it comes from. So basically, the quadratic formula is completing the square, but it saves you physically completing the square every single time. You just plug into the formula. It's that idea again of patterns. If you know it's a pattern, well, then we use that to our advantage. Another way of doing completing the square is like this. I go, okay, x squared minus 6x plus 6. I say, well, I'm going to turn this into a difference of two squares question. Now, if I complete the square, the constant's irrelevant for now. I'm just looking at the x squared minus 6x, and I know it's always going to be x plus or minus whatever the coefficient of x is, but half of it. So I know this will be x minus 3 all squared. But of course, if I was to expand that out, I wouldn't get 6. I'd get 9. So in order to get back to 6, I would subtract 3. And I've now got a difference of two squares. So it factorises to be x minus 3 plus root 3, x minus 3 minus root 3. And now we've got that idea of, two things multiply together give 0. So either x is 3 minus root 3 or x is 3 plus root 3. That's another way of thinking about completing the square. Certainly comes in useful when we start playing with imaginary numbers, because you can turn sums of two squares into differences of two squares using imaginary numbers. But anyway, don't need to know about that now. Okay, so 1H, we'll have a go at some of those.